Have you ever seen images such as these? These are color infrared images. Red objects in these images are very reflective in near-infrared radiation. This video will give you an introduction to near-infrared aerial photography, both what it is and one of its most common applications. Now, to start with, we'll take a look at the electromagnetic spectrum. In the middle of the spectrum, we have what's known as visible light. That's the red, green, and blue. That's the portion that the human eye can see. The sun, on the other hand, emits a much broader range of wavelengths, far beyond what the human eye can see. And the portion of the spectrum with wavelengths just shorter than the visible is the ultraviolet band. And we cannot see this band, though it is a major player in the commercial success of the sunscreen industry. Now, the portion of the spectrum with wavelengths just longer than the visible is the near-infrared band. Now, it's very important to not confuse near-infrared radiation with far or thermal infrared radiation. Far or thermal infrared radiation is emitted by hot objects through a process known as thermal vibration. Thermal infrared radiation is detected with an imaging technique known as thermography. On the other hand, near-infrared aerial photography uses reflected near-infrared radiation from the sun. The chlorophyll in healthy vegetation is very reflective in near-infrared radiation. The human eye cannot see it, though our cameras can. One frequently asked question is, if looking for vegetation, why not simply look for what is green? And the answer is that there are many green objects that are not vegetation. And here we have a photograph with quite a bit of green in it. We have a green hedge, some green leaves, green trash can, green mailbox, and a green tarp. Let's take a monochrome near-infrared image of this scene, and we can see that everything that is vegetation becomes very bright, while the other objects that are green but not vegetation don't reflect the near-infrared and appear very dark. Now, a color infrared image renders all the near-infrared as red, and once again telling a completely different story than our original natural color image. And now we will take a quick flight to go look for some vegetation from the air with our near-infrared cameras. This flight will take us out to Anacapa Island. Anacapa Island is part of the Channel Islands National Park, just 13 miles off the Ventura, California coast. And now we will position our aircraft directly over the top of the island, and we'll take both natural color and color infrared photographs. First step, we will merge these four images into one, then zoom in on the right half of the image, and looking closely, this appears to be your stereotypical desert island. There's a little bit of green on the surface of the island, which might be grass, but for the most part, there does not appear to be any vegetation. Now, the color infrared image tells a completely different story. While we see the red grass on the surface of the island, the surprise is the kelp in the water surrounding the island. And this kelp was not visible at all in the natural color image. So this is a good example of how near-infrared aerial photography can detect vegetation when natural color photography cannot. Detecting vegetation is very useful for assessing damage after disasters such as fires or floods. This type of photography can also be very useful for assessing the health or vigor of vegetation and finding disease such as phylloxera or infestations such as bark beetle.